Hello again, my curious engineer. In the previous lesson, we moved beneath the black surface of the Atemiga 328P. You saw the core, the memories, the pins, the timers, and the quiet machinery waiting inside. And one question remained open. If the microcontroller already contains so much, why place it on a larger board? Let that question stay with you for a moment. Keep the small tension warm, because the answer begins with one important distinction. The Atemiga 328P is a microcontroller. Arduino Uno is a development board built around that microcontroller, and Arduino itself is larger than either one. The word Arduino can refer to boards, software, libraries, design conventions, documentation, and a broad ecosystem created to make microcontrollers easier to approach and use. Not less real, not less technical, simply more accessible. You may think of the microcontroller as the hidden system capable of sensing, deciding, and responding. The development board brings that system outward, gives it convenient power, visible connections, a path to your computer, and a structure your hands can work with. The chip remains the heart. The board opens the body around it. And while that image settles, notice how the two belong together without becoming the same thing. A development board is a ready-made circuit built around a microcontroller. Without one, a bare Atemiga 328P still needs support. It needs power and ground. It needs decoupling capacitors to keep the supply stable. It needs a reset arrangement. It needs a clock source or a suitable internal clock configuration. It needs a way to receive firmware, and its small physical pins must be connected carefully to the rest of the circuit. None of this is impossible, but each requirement creates another point where a beginner can make a mistake, another wire, another uncertain contact, another moment when the system remains silent and does not yet explain why. Arduino Uno removes much of that friction. It provides convenient connectors, a regulated power path, reset circuitry, a clock system, status LEDs, a USB connection, and a practical way to upload new firmware. The board does not replace the microcontroller. It supports it. It surrounds the chip with the conditions it needs, holding power steady, guiding signals to the right places, and making each connection easier to reach. You can still move deeper later. You can still use registers, programmers, and custom boards. Arduino does not close the system. It gives you a softer entrance and leaves the deeper structure waiting underneath. The word Arduino is used in several related ways. First, Arduino is a project and an organization that develops hardware, software, documentation, and educational tools. Second, Arduino is a family of development boards. Uno, Nano, Mega, Leonardo, Micro, and many newer boards all belong to that family, even though they do not use the same microcontroller or the same architecture. Third, Arduino is a software platform. It includes the Arduino IDE, the build tools, the Arduino core, libraries, and the upload process that turns written code into firmware inside a chip. And finally, Arduino is an ecosystem. Official boards, compatible boards, shields, modules, libraries, tutorials, examples, and a large community all meet around a shared way of building embedded projects. So when someone says Arduino, the word may mean the physical board on the table, the software on the computer, or the larger environment connecting both. You do not need to force those meanings apart too quickly. Let them arrange themselves in layers. Hardware below, software above, a set of conventions between them, and around all of it, a community that has spent years making the first contact with microcontrollers easier, clearer, and much less lonely. Each layer touches the next, and together they make one coherent way to create. Now, look at the Arduino Uno itself. At its center is the Atmega 328P, the same microcontroller we examined before. Around it, the board adds support. The USB connector gives the board a physical path to the computer. A separate USB to serial circuit translates USB communication into the serial signals used to upload firmware and exchange data with the Atmega 328P. The power circuitry allows the board to receive energy from USB or an external source and distribute suitable voltages. The reset button restarts the microcontroller. The clock circuitry gives the Atmega 328P its familiar 16 MHz rhythm. Headers bring the microcontroller's pins outward into larger, labeled contacts that accept jumper wires, shields, and test equipment. LEDs show power, serial activity, and the state of a built-in output connected to Arduino pin 13. There are also ICSP headers for direct programming and SPI access. Today, you do not need to memorize where every component sits. For now, allow the board to become legible, a connection to the computer, a path for power, a rhythm, a reset, pins brought outward, tiny lights that answer when activity passes through. The larger board is not decoration. Every visible part exists because the small chip inside needs a practical way to meet the world. One of the most important pieces is the bootloader. A bootloader is a small program stored in a protected part of the microcontroller's flash memory. When the Atmega 328P resets, the bootloader briefly checks whether new firmware is arriving through the serial connection. If an upload begins, the bootloader receives the new program and writes it into flash. If no upload arrives, it gives control to the user program already stored there. This small pause at startup is what allows ordinary Arduino uploading without using a separate hardware programmer every time. Follow the path slowly. You write a sketch on the computer. The tools compile it into machine instructions. The computer sends those instructions through USB. The USB to serial circuit converts the connection. The bootloader receives the data. Flash opens, holds the new firmware, and after reset the CPU begins to execute it. Text becomes instructions. Instructions become voltage changes. Voltage changes become light, motion, sound, measurement, and response. And there is something quietly satisfying in that transformation. A thought written at the keyboard, entering the board, settling into memory, then returning to you as physical behavior. A small delay, a brief opening, and the old program yields to the new one. Arduino also simplifies the software side. The Atmega 328P is controlled internally through hardware registers. A register is a small storage location whose individual bits configure or report the state of the hardware. For example, one register can decide whether PB5 is an input or an output. Another can make that output low or high. At the register level, turning on the built-in LED may involve names such as DDR-B, Port B, and PB5. Arduino lets you express the same intention more directly. Pin mode 13, output, digital write 13 high. The simpler functions do not create different hardware. Beneath them, the same registers still change, and the same physical pin still rises toward the supply voltage. Arduino provides an abstraction layer, a simpler language placed over lower-level details. That layer can make the first movement feel smoother, less resistance at the surface, while the exact mechanism remains present below. Later, when you are ready, we will move between both levels. You will learn the convenient functions. You will also understand what they touch underneath. Because the goal is not to hide the machine forever. It is to let you enter safely, gain confidence, and then choose how deep you want to go. The surface stays gentle, while the deeper mechanism remains exact. The Arduino tools also manage the journey from source code to firmware. A microcontroller does not understand C or C++ text directly. The code you write is processed by a compiler. The compiler translates it into machine instructions for the specific processor architecture. The Arduino core adds the standard functions and startup behavior used by Arduino sketches. Libraries can add support for displays, sensors, communication devices, and other hardware. The build system combines the necessary pieces, checks them, converts them, and produces the binary data that can be uploaded into Flash. Then the upload tool sends that result to the board, so the path is not magic, even when it feels smooth. Sketch, core and libraries, compiler, machine code, upload, Flash, execution. Keep that sequence for a moment. Let each stage touch the next, because later, when an error appears, you will know where to look. A problem in code is different from a problem during compilation. A compilation problem is different from an upload problem. An upload problem is different from a circuit that receives the program correctly but behaves incorrectly. Arduino softens the path. Understanding the path gives you control over it, and once the sequence is clear, the smooth surface no longer hides the machinery. Arduino makes the entrance easier, but it does not remove the laws of the hardware beneath it. The Atmega 328P still has limited memory. Its pins still tolerate only certain voltages and currents. Its timers, communication interfaces, and analog channels still have specific capabilities. A library cannot create a peripheral that the chip does not possess. A simple function cannot make an unsafe load safe to drive directly, and a beautiful board cannot protect every circuit from an incorrect connection. This is why we will learn both layers, the accessible Arduino layer and the physical microcontroller beneath it. One gives you speed, the other gives you understanding. Together they give you choice. Now the earlier question can release its tension. Why place the Atmega 328P on a larger board? To make power easier. connections clearer, programming simpler, experiments faster to bring the hidden system outward, close enough for your hands, your code, and your curiosity to meet it safely. The Atmega 328P is the microcontroller. Arduino Uno is the development board around it. Arduino is the wider hardware and software ecosystem connecting the two. In the next lesson, we will look closely at the Uno itself, component by component, and discover what every visible part is doing there. And if you stayed until the very end, this little secret is only for you. Perhaps you can keep that warm spark of curiosity and let it move a little deeper, slowly, safely, until tension becomes pleasure and your body remembers how naturally it can respond.